Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum and very good day. So today I want to brief you how to use Euclidean diagram and extended Euclidean diagram, because somebody asked me still not understand about the function of the Euclidean diagram and extended Euclidean diagram. So as we know, in our lecture slide we already have Euclidean diagram and then extended Euclidean diagram. So this one is extended Euclidean diagram. Okay, for Euclidean diagram we can use to find GCD. Okay, we can use to find a GCD. Okay, greatest common division. Okay, previously we already learned how to find greatest common divisor or by using the concept of prime factorization. But in this time we are using Euclidean algorithm technique in order to find greatest common division or GCD. Actually a similar thing, but this technique is another way to find the GCD value. Okay, how to do that? So let's say by given the example and the question asking about the find the GCD for 414 and 662. Okay, by using a Euclidean algorithm. How to do that? Okay, firstly we need to know what is the balance of this number. Okay, 662 minus 414. Okay, so that's the first thing. Okay, 662 minus 414. Okay, so the balance is 248. Okay, so that's why we need to come out this equation. Okay, so the right part is the balance, meanwhile the left part is the number that we will using. Okay, so 662 equal with 414 times 1 plus 248. Okay, 248 actually the meaning of 248 actually is a balance or remainder. Okay, okay, like this. Okay, and then how to come out with the second, third, fourth and fifth equation. Okay, how to come out? Actually firstly from the first equation, just reserve this number 414 and 248. Okay, and then for this number you just bring this number down like this. Okay, and then 414 and then equal with 248. Okay, equal with 248. Okay, and then obtain the remainder. How to obtain the remainder? Just a minus 414 minus 248. Okay, and then you obtain 166. Okay, so is it this number is less than 248? The answer is yes. And then since this number is less than 248, then you can write the balance like this. Okay, so 414 equal to 48 times 1 plus 166. Okay, this one means remainder or balance. Okay, and then after that bring this number down to 48 here and 166 is here, and then do the calculation in order to obtain the remainder. So 248 minus 166. Okay, then we can obtain 82. So is it this number which is 82 is less than 166? The answer is yes. Okay, so that we can stay with this number. So here after that we can calculate or write the equation like this: 248 equal with 166 times 1 plus 82. Okay, so 82 means remainder or balance. Okay, and then we bring this number down, 166 go down and 82 go down. Okay, and then we need to calculate the balance. 166 minus 82, 82. Okay, then we can obtain 84. Okay, so the question arise 82 and 84, which one is greater? of course 84, but since this number is balanced, so this number should, I mean don't should greater than 82, must be lesser. Okay, so that's why we cannot put 84 as a balance. Okay, so we need to increase this number. How to increase that? With times with 2. So there is a trigger, times with 2. So 166 minus 2 times 82. Okay, then we can obtain 2. So 2 is the balance. Okay, so we represent this number like this: 166 equal to 82 times 2 plus 2. Okay, 2 is balance. Okay, and after that we bring this number down, 82 and 2, and then 2 82 82 minus 2, because we want to obtain the balance. 82 minus 2, the balance is 80. But however, this number is greater than 2. Okay, 80 is greater than 2. So what we need to do is we need to find a way how to reduce the balance. We need to make sure this balance is lower than this number 2. So how to do that? We need to increase this number by times with other number. Okay, like this, maybe like this. The trick is like this. So 82 minus maybe 2 times 41. Okay, then we obtain 0. Okay, okay, so that's why we come out with this. Okay, this is the last equation. After we come out this kind of the equation, now it's time to obtain or determine the last non-zero remainder. Okay, as we can see like this part is the remainder or balance. Okay, so which number is the last non-zero remainder? Of course 2. Okay, so that's why we saying 2 is the last non-zero remainder, and then this number, which is last non-zero remainder, will be our GCD value. Okay, so that's why GCD is equal with 2. Okay, so D is for Euclidean algorithm. Okay, next part is extended Euclidean algorithm. Okay, for information, extended Euclidean we can use to find linear combination. Okay, we can use to find linear equation. This one is extended Euclidean algorithm. That's why we call as extended Euclidean algorithm. Okay, so how to do that? Firstly, we need to know the formula that we can use inside extended Euclidean algorithm. Okay, the formula is here. Okay, we need to make or come out an equation by using this form, which is GCD AB equal to SA plus TB. Okay, and meanwhile S mean S and T is a linear combination. Okay, so we go to the example. Okay, firstly, as usual, we need to determine the GCD value. Okay, by given the example, express GCD. Okay, equal to 18 as a linear combination 252 and 1 8. Okay, so here in this equation, in this equation, we need to prove this number, which is 252 and 198, is a linear combination of GCD value. Okay, so firstly we need to determine the GCD value. How to determine? Okay, as I mentioned before, we can use the previous technique, which is I already tell you, like this. Okay, okay, we need to, after we come out this kind of the equation, okay, we need to obtain the the last non-zero remainder, which is 18. Okay, this is the last non-zero remainder. Okay, for information, the right part is the remainder. Okay, and then 18 is the last non-zero remainder. So 18 is the GCD value. Okay, so Now it's time to find the linear combination. Okay, how to find it? Okay, so how to find it? Firstly, we need to know, we need to do the planning. Okay, we need to come out with the new equation. From this equation, we need to come out with a new equation. Okay, such as 3.1, 2.1, 3.2, and 1.1. This one is a new equation that we obtain from here. Okay, the reason is we want to make our equation, I mean the last final equation, will be like this. We need to form our last equation will be like this. So GCD value equal to SA plus TB, which is S and T is a linear combination. Okay, after we obtain the GCD value, okay, so we already know GCD value is 18 kan. Okay, so we already know, so we need to reserve this equation and come out a new equation from this third equation. Okay, why we need to come out? Because we want to reserve 18. Okay, because you at the final equation, uh, we want to make sure the GCD value is the in front of the equation. Okay, because the equation that we targeting or we want to form is like here, GCD value. Okay, so the GCD value is 18, and then we want to make this number is in front. Okay, so like this. So that's why we need to come out with a new equation. Okay, understand? So that's why we reserve this part. Okay, and then next part is the next target. We want to find the y value or another value, another parameter value, which is this one, t. Okay, okay. In the class, I already teach you as a t as a xy. So, but in this slide, you can I present as a st because this slide is done by the other lecturer. Okay, actually it's similar thing lah. Okay, so the thing is we already make the GCD value appear in the equation. Okay, but this time we want to make t value is I mean not t value, y value appear in the equation. How to do that? Okay, y value here is this one, y98. This one is a y value. Okay, why I say this one is y? Because GCD AB, sorry, GCD AB, this one refer to B, which is y. We can also call this one is a y. Okay, so for y, I mean for B is here. Okay, D is the equation that showing B value. Okay, so that's why we reserve this equation. Okay, by manipulating it and come out with a new equation. So 36 equal to 1/8 minus 3 times 54. The thing is, why we need to come out the new equation? Just use only can. But however, we need to see the form. The location of the B is here. Okay, not here. I say also here, but the location that we aim is here. So that's why we need to come out with a new equation. Okay, so 1/8 we want to make at the right part. Okay, so that's why 1/8 we need to come out like this. Okay, because we want to make 1/8 at the right part. Okay, so it's time to mix 2.1 and 3.1. The reason is why we mix it, because we want to make make the value of the GCD and B inside the equation, because as we can see, this equation just showing B value, right? But however, this equation just showing GCD value, which is 18. Okay, okay. In order to make the value of GCD and the value of y appear in one equation, we need to mix it, right? Okay. Okay, so that's why we need to mix it, and then finally we come out with a new equation. Now we already successfully mix the equation and come out with the equation that showing GCD value, this 180, and B value. Okay, so this one is B value. Okay, sama tak? Kan, tengok ni, sama kan? B value GCD. Okay, now it's time to obtain or to find the A value. Okay, so this one is A value. How to find A value? A value here. So A value in this example is 252. Okay, so A inside first equation. So from here you want to come out with a new equation like this. Okay, so this one is A value, and then we need to mix it, this one and this one. Okay, the reason is this one contain GCD and B value. I mean GCD and B value, and this one contain A value only. And then if we miss it, then we can showing all the value. You see, we can showing GCD value, we can showing A value, and we can showing B value. Okay, so that's why we mix it like this, and then finally we can showing GCD value inside our equation. GCD value, A value, and B value. From here, now after we forming the new equation, then we can obtain the linear linear combination. So this one is a linear combination. Okay, so I think that's all for my explanation. Let's say if you have any question or other thing that you still not understand, please let me know. Maybe you can come to my office, and then I will showing or explain you further. Okay, thank you. Don't forget to submit assignment and also tutorial. Thank you very much.